let's get started. First off, let me introduce you to our melting point apparatus. It's obviously a great tool for organic chemistry if you've got classes where you're designing and synthesizing compounds. That it's one of the early sort of properties that you will be studying. Where does this substance melt? And over what range does it melt? It's pure as the range of those temperatures is closer together. The other thing that's stand out for us is that it's a very small sample size. I'll pull out the sampling tube right here. These are just capillary tubes, very small. You're talking about milligrams worth of substance to test. So if you've got some substance that it doesn't take much to be able to watch and follow to get that melting point. The Pasco advantage of using sort of the design that we have in this system is that, let me switch over to that view. The device comes without a camera, and it will have a 3x eyepiece, which should be then like every normal melt point I used when I was in grad school or when I was teaching or when I was in organic chemistry. You will have the powers on one side here. Let me just turn that real quick so you can see. The power slide is right down at the end, and then the plug to drive the heater will be on one side. The camera comes as an accessory, which we'll point out here on the next slide. But that really adds some great value too. Each of the setups, when we see the internal, like how do you set this going, we've got different temperature ramps and different kinds of things that can happen. Quickly ramp close to the melting temperature. You can quickly then let it sit so that the whole area becomes the same temperature. So we've got these settings that really help to save you time. When it's done, we've got a fan mode to cool it down. And then, of course, if you've got the camera attached, that you can then go back and forth to reassure yourself that you understand what the melting temperature was. So those are some advantages that we really stand out. The product numbers, PS3239 is the melting temp apparatus. The 6215 is the camera that is used. It's an eyepiece camera, and others can be used, but these are the ones that we have taken the time to make sure they work with all our software. So you see in the background the running software that's in ChemView, but it can work in any of our softwares. It will have a very similar feel for it. So actually, let me go ahead and let me step out of this so you can see what the program looks like that runs these. I'll move this off to the side and bring over, actually, I'll just bring over the ChemView. Okay, so if I am in ChemView, let me maximize this so you can see that. When you start off, you're going to see different sides. We've got, just like in our other ChemView sort of software, we've got usually just 3 to 4 sort of tabs across the top. The first tab is for the setup. It's the setup tab. And you will be able to, first of all, say, hey, let's connect to a wireless melting point apparatus. What's wireless about this is that it's sending the temperature data back over to the computer. Of course, the heater requires quite a bit of electricity, so that's through a plug-in. And you can select which, sort of the temperature you're viewing, which is built in right at the heater source. You can choose which camera you want by clicking here and choosing the MD100. That's what we're using. That's the camera that looks as the product number. You can add steps here, but we also have so that you can, if you'd like, to get in and let me go into recording mode, select different temperature profiles. Most often, organic chemistry uses aspirin, synthesis of aspirin, synthesis of or isolation of caffeine. So those two are set in there so that they would be a good example. So you can choose those. You can go into any one of these steps below then, if you choose, one of these defaults, which I did. That's what we get in here. You can quick ramp it up to close to the temperature. Well, here, so notice this says 127 right now because I wanted to go a little lower to get this. If I go to aspirin, what's the most common, particularly if a student is synthesizing it, they make a much purer form of aspirin than you can buy generally at the store. Store puts in some other fillers, which will cause the melting point to lower. So that's one thing I did when I was running this, is that I went inside. You can change any one of these steps, which is nice. Then the quick ramp, if I want, just double click that, and down at the bottom, I can say, oh, you know what? Let me make sure I don't accidentally get too close to the melting point. So maybe I'll go to 127 and then start taking pictures. It'll hold for 10 minutes at that point. Well, if you say, you know what, I think 4 minutes is fine. If you're, want to cut a few minutes off of waiting for that whole area to become the same temperature, the accuracy of which improves greatly when it's, all the whole body of the little capillary tube gets the same temperature. And then you're going to start taking images. Obviously, if you're going to start taking images from the very beginning, a movie, it's actually a movie that you're going to take all the way through, you're going to add a lot of, movie that isn't interesting. So generally, we start after we've gotten to the hold place where everything's at the same temp and then slowly ramp it. That's the second kind of ramp that we put in here. And you'd say, well, it's going to go from 127 to 137 or 10 degrees in 4 minutes. That's about a 0.25 degrees per minute. That's a nice slow crawl up there. And this sort of illustrates what that looks like. This isn't the actual temperature, but it gives you an idea of what the ramp will look like. And then when you're done at the end of that 4 minutes, you're going to stop the image capture and it'll stop the file. So you can put in other ramps in here as well if you choose, but this is the general format that would normally happen. You can run the recording from here. You can also, if you're doing multiple steps, you can do things like, hey, let's manage each of the runs. I've run 3 steps and given them the name of each type of aspirin so that you would see, oh, okay, yeah. I think a cool example would be, let's get a brand name to see if it's any higher quality than just a generic aspirin, and then compare that to baby aspirin. And so I made 3 runs. Each time I made a run, I renamed it so I could remember what was there. Once you're done with the run, what's nice is that when it's running, if I hit the record button, then you'll start to see some numbers here, but not until then. It would be ready once we've got all of that set up. I've got a run that's recorded, and so you can see I would be able to get into here and play or scrub back through the image, which is really nice. So which run you're talking about is controlled down at the bottom. So I made my 3 runs. Here's my brand name, the very first of some aspirin. The normal 325 milligram supply is what's called regular. There's extra strength, which is 400 milligrams. And then there's the 81 baby aspirin. But then you can, once you've run it, you can go back and forth. And I know as a college student, I've been looking at these and I say, well, is there some change happening? Is there some change happening? And then if you look in the image, you're going to see, oh yeah, look, there's some change that goes on. But it'd be really nice to say, when does it really start to melt? It gets slushy there for a little bit. And until I start to lose some volume and I see my first drop, it's starting to look, like I say, a slushy and fill the bottom of that tube. It still hasn't lost its sort of normal volume. There we go. Now we see it start to, collapse down into just a liquid. And so at that point, then the student has a much better chance, especially when you're first or second or third time you've done these, you're always second guessing yourself. And once that's happened, it's beyond, going back to see, but having this sort of capability to go back and forth really helps you to understand and trust in those measurements because usually it takes 40 minutes or so. What's nice is that the speed at which this happens, because we have that fast ramp, notice, let's go into the second view, which shows actual temperature as you're running through this. If I'm running this first run, which is that red run, you're going to see it here. Let me turn off the other 2 runs. Oops, we keep the red run. And I'm replaying the red run. Watch what happens as we go back. The temperature also gets back to the places where we were recording. Remember, this is just not, it's not corresponding to pictures. So yeah, you go through this run, it gets close to the temperature. Once you get, the 127, it's going to hold it for 5 or 4 minutes, what we told it to, and then it's going to start taking pictures. And so look, you get that last little bit and you get the time correlation and the temperature correlation so that you can see what's going on. That really makes it nice then to ask some good questions. All right. So that's the way these run, how you can get to look. If you want it to be a very big screen, there's still one last view of this. Let me maximize it again. That way you really see what's down inside of the spectrometer that's here. Let me pull this back. And that you're going to see everything that's going inside of the spectrometer as you're looking at this. And that gives you even more detail that can be looked at and make some decisions about. You'll notice I've run two different capillary tubes each run, because the first one was, like I said, a brand name. That's the middle one. The second one, I have a new substance, and that's the generic aspirin. Let me go back a little bit. And at the same time, I ran a third unknown. We had a pill that was in that was in there, and we wanted to see, was that aspirin or was it generic aspirin, or what kind of aspirin was it? And then the last one, the baby aspirin, I ran that on the left, and I kept this one because we never reached the temperature until this very last run of this one on the right. We wanted to see what the heck is that unknown aspirin. It was just sitting on the table, been taken out but never used. So, all right, let's get on to then the results. That's what our three views look like. The setup page. Here's the data collection page where you can see both the graph and the the melting happening. That certainly beats, as a grad student or college freshman in chem and organic or sophomore in organic, you're sitting over that, and if you miss it because you stand up and your back is sore because after 40 minutes of looking, it's really nice to move and see them both right here where you can see both things happening and the ability to go back and forth. And then last, you can see sort of the bigger picture with smaller data off to the side. Okay, so let's take a look and bring this back up. And what did we find out? First, the commercial run aspirin. Okay, here we have some aspirins that we collected some pills from, and we scraped the material into those little tubes and put them in. Is that we noticed when we were melting, I'll go ahead and hit the play button. This is a movie of that same run. I'll just take this way out here, and we'll get right out to the point where, yeah, we're at 133, 134. It's get slushy, and finally come to this point right there that is 135 to 136. Very good, because aspirin melts at 136, and this is a very narrow range. So we're right on in terms of temperature where the aspirin should melt, and the range is 0.16 degrees. Okay, let's go on to the next one. The next one on run 2, here's the generic aspirin. Here we see it melts at 126, and it has about a 2/10 of a degree range, so about twice the range, and about 10 degrees Celsius cooler. Okay, that doesn't mean it's not bad. I mean, aspirin always has had fillers in them. It just means that in here there is more fillers that are causing that melting point to lower. Get right towards the end. We'll see if there's any kinds of change. Probably have to hit the play button though. Oh, I passed it. I'm still showing the old one. Yeah, you can see here, right around here is where that melting occurs. And it's just fascinating, and it's great practice for students to watch to see, to get these numbers. 10 degrees lower than normal, and it's 0.21 spread, generic aspirin. Okay, let's go to the third one, baby aspirin. I'd think, it's a much smaller amount. 81 milligrams is a baby aspirin. Maybe that still means there's still way more filler because the pill is the same. And you see, no, this is actually a little better than the normal generic aspirin. It's actually from the same manufacturer of generic. So the baby aspirin is actually a little cooler because it's only 8 degrees lower than normal. The more things you put into a substance, the lower its melting point will go. It's not as pure. Now, or a chemist at college that separated these, sophomore organic student should be able to get within 2 degrees. I don't remember what my grades were dependent on. I think, half a degree, I think I would have lost a grade if I was only 0.5 off of the melting temp. But here we can see the range of which this baby aspirin melts is also 0.67. So it's right in between the two, the fully name brand aspirin and the generic. So what we see is these are a great measure of quality, of purity, of how pure that aspirin is inside that tablet. And will this still do the job? Absolutely. There's enough aspirin in there that will do its work, but in terms of grade or chemical grade for getting pure substances, that's what our, my advisor, my class professor used to grade me. So now let's go to the last one where I found a bottle and, probably was packing for a trip or something. And I threw a couple different kinds of aspirins in there. And when I ran this one was interesting. You saw it was always the side one on the right side running all 3 times. That means I never quite got up to the temperature that I was hoping to get it to melt. And so I kept it going a little higher each run from the natural the name brand to the generic brand. The third time I ran it with baby aspirin, I finally ran it several degrees over to get it to melt. And so when we did, I saw it finally gave up right in here. Let's take a look and see what that ends up looking like. Oh, I just took a snapshot picture. That's all. I was trying to figure out why that wasn't a movie, but it's on the last step. As a matter of fact, there was a little bubble, and when I saw that bubble able to move through the liquid, I knew it finally melted. So it's higher. So the question is, what does that mean? Is it aspirin? Well, I went and looked up all the other kinds of aspirins melting temperatures, and the first one I found was that ibuprofen as a painkiller. Could it be that? 77 degrees. No, that's way, way too low. So that wouldn't make sense for 138-degree melting. It took a look at aspirin or acetylsalicylic aspirin. That is 136 degrees, and it's a little higher. So I would think maybe this is something else. Acetaminophen, Tylenol, oop, I spelled that wrong, is 169 degrees melting point. And then naproxen, which is a leave, as one commercial brand, is 260. So that's even higher. So then the question was, wow, okay, it's not any of the common pain relievers. Did I take something crazy if I would have eaten that tablet? The truth is that there's still, I thought, well, maybe it's not even an aspirin tablet. Maybe it's a caffeine tablet. Well, that's even higher. Caffeine's even got a higher melting point. But what's cool is that there are some aspirins that put a touch of caffeine in because some people get headaches that are related to caffeine, maybe withdrawal, that they need that, or we drink enough caffeine as a nation that they need that to sort of settle the brain. It's just not used to it. And as a matter of fact, one brand name does exactly that, and that combination for them does melt about 3 to 5 degrees hotter, which would make a lot of sense that maybe I had this name brand based on its melting temperature. And so those were some great ways I could tell, even not just the substance, but what combination or mixture of substance or even a brand name. If we knew, hey, this is definitely a brand name aspirin looking tablet, let's figure out which one's which. The melting temperature alone would help us to calculate those. So really a fun kind of an exercise as we're going through this. As a chemist, in my organic chemistry, I would take my sample that would be on like a filter, and we would scrape those off, and then I would put it onto a capillary tube, and I would turn this in. And if it was, like I said, less than a half a degree off of the main melting temperature, I'd probably get an A. If it was from a half to 2 degrees off, I'd probably get a B. And if it was more than that, I would be told to go back and purify this again by dissolving it and recrystallizing it. But all of those are fantastic, and it gives me the confidence, even after the third or fourth run of different chemicals, I was still guessing at what should this look like when it's melting. And boy, when it's right in the software to go back and forth and see it collapse and you can see all the details, you start to ask some other questions. As a matter of fact, if we went back, let's go back to this first one. I noticed when this one melted, let me play that again. You'll notice that in the slide, let's come way out here. When it melted, watch when it sort of goes back down to a liquid here. You'll see that not only does it melt, but then there's that cool, notice there's some materials in there that are settling or dissolving. So is that still, stuff that it's not dissolved? It's actually physical material that doesn't dissolve in the liquid aspirin, the melted aspirin. All of those are great questions and would lead to further kinds of studies. So what I like about it is because you've got the images, you'll see things that you can then pose more sort of ideas and questions about in this phase change sort of a process for chemistry once you get to this. It's an end of the year topic. If it's, if you're talking about in high school, we always talk about, gases, then liquid solids, and then mixtures. And that's the rest, like acids and bases are a mixture. And then, reactions we talk about mixtures and reaction rates. So it still could be a great even tool to have one of around in the high school lab, especially for AP, to sort of see some examples of differentiating between chemicals using a tool like the melting point. So with that in mind, I think that's really a kind of cool way to see and ask more questions than just what you would normally get, which is a raw temperature. And if you're making aspirin, the temperature it's supposed to be. So you can set all those conditions inside the software, and it'll go much quicker. Not only did it take 30, 40 minutes, but can you imagine a room of 20 students having to wait? Once a student is done, it's going to take 40 minutes. So you maybe get 2, 3 students to get through in a classroom to do their studies. The heating rate is amazing. It's about 2 minutes to 100 degrees, about 5 minutes to get to 200 degrees, and then maybe 10 at the top of its range, which is 360 degrees, which we talked about were some of the sort of the benefits of Pasco sort of equipment, is that we made it to really go above what normal organic compounds really melt at, but you can still do things like nitrates that melt, lower for ionic compounds and some common melting substances. All the labs that you can do on these, we have a system now that is called the portal. And as schools move more towards learning management systems, let's say you have a lab that's on there, any of our labs that we would have would be available. Is nice to put in some content area and be able to transfer it if you're teaching with a learning management system like Moodle or Blackboard or Canvas. It's nice that we'd be able to take right from inside of our portal, and we'd be able to push those or have it be able to be pulled into your learning management system, so that that would help you as a teacher when you're preparing your classes. But if you want to take a peek at that, we have free access until the end of this month, and you can just kind of play around in there. You can either go to pasco.com/portal-free-trial, and take a peek in the next, through the end of this month, next month, see how that works, to see if it's something. It's all of our labs, all of our professional development, access to the textbooks, not for students, but for teachers, so you can see what those look like. And it's a great way in terms of chemistry, to see what we have. And as that's becoming available, our demonstrations or our simulations are there, so you can even see if you want to use one or two of those as a classroom demo. Go ahead and use that. Go to that URL, or if you can take a screenshot with this QR code and then follow that up. Or if you take the quiz at the end, then you're going to get this presentation plus the film. So with all of those things in mind, I'm going to take just a second before I take the next step and see if there's any questions that have come up. Nope. Awesome. So what did we just learn? We learned that as melting point can tell what a substance is and how pure it is. We looked at 3 aspirins, name brand aspirin, which was very pure and right on the money. Some of the generics were 10, 8 degrees melted lower, so they aren't as pure. And probably that's filler. That's not something that we be concerned as far as taking it. It's a non-active starch or something. And so it lowered the melting point. And then the last one was we found a mystery pill, and we said, is that aspirin? We were able to tell its substance because it melted higher. And as we look to see what substance is it, it's way out of, it had to be somewhere close to aspirin, but it's still above. So it wasn't just that. We saw and reasoned that it very much could have been one of the aspirins that may have had some caffeine in it, causing the temperature to actually raise its melting point. So with that in mind, that these are something that looks like it could be a great tool, or any of our tools for that matter, as you spend time in terms of chemistry. We have a great line of materials that you can take a look. Pasco.com/support. If you are on our website, you'll be able to ask questions. They'll answer very quickly. You can find out who your region person is if you have some questions specifically, if you want to talk because of where you're at, and see, sort of what they can do for you. We'd love to have you check that out as well. Pasco.com/support, or the QR code here. When we're done, what I'm going to encourage you to take a look at is you'll finish, and then you'll get a post-webinar survey. It's only a few questions. If you have some comments, please feel free to jot those in. And that way you can, then you'll get an email immediately after. Well, tomorrow. You'll get an email tomorrow with the link for the webinar today, and the PowerPoint that I used, plus the ChemView experiment that was of those. If you want to see what that looks like, that you'll get all 3 of those in that post. But I will give some time if there's any further questions, now that I gave you a minute, just a few minutes ago, to ask. But thanks so much for what you do. I know we're coming down to the end. If you're in the college sort of settings or university settings, it's probably the last few weeks. And if you're at the high school, you probably have a month yet to do. But thanks for your commitment to teach with our materials that gather data, or any of those kinds of ways to help students make choices and understand data. The world is complex, and they need help to see those, and having small instruments like these, like our melt point temp, is going to help them in their lifelong choices when they see and have to make choices about information that comes across, and they understand how it's measured. So with that in mind, I wish you the best. I wish you a great teaching, and have a great day for us here from Pasco.